Hello, I'm Isaac, a tutor at CWI, and today I'm going to be working through Physics 111 Practice Exam number 2. This is problem 4. I think it's probably the most challenging of all the problems on the test that I've looked at so far. It gives us a picture and it says, if a force on this block is 40 newtons at 30-degree angles from the surface parallel, and this block is 2 times the mass of this block, assuming the system is frictionless, what is the magnitude of the acceleration of the suspended object, or m? One thing that I like to do right off the bat, because this 2m thing and this n thing, I'm going to forget that that's 2m and that's m, and so I like to immediately start by saying, I'm going to call this mass 1, and I'm going to call this mass 2. And we see that mass 2 is 1m, so that's 2 kg, 2 kilogram. And this is mass 1, and it's double that of mass 2, and so it's 2m, or 4 kg. And that's something that helps me to keep the problem organized. I always have a few questions that I try to answer when I look at a problem like this. My questions have to do with external forces. An example of an external force would be gravity, or the force that's being applied here. But I will not consider a normal force a direct force. It's a reaction force because of Newton's third law. So if we look at our force for this block, my first question for this block is, does it stay on the surface? Because you'll notice there's a force pulling it up. If the block goes off the surface, we can't solve the problem. So let's start out by saying the sum of forces in the y direction equals 0. So in other words, we're assuming it's a static system. And we're going to take a look at the forces. Actually, let's look at it this way. So if I have a force upward caused by this force right here, the 40 newtons, because we're looking at the y direction, that'll be sine of 30. So force times sine of 30. And then the other external force that we have on this block, M1, is we have gravity. So M1G. And we're going to solve for these numbers. And so let's get the calculator. So this force is 40 newtons, so sine 30 to find the opposite, times the force, which is 40 newtons. That gives us a result of 20 newtons. So we have a 20 newton external force pulling up. And then downwards we have M1G, and M1 is 4 kg, and G, of course, is 9.8 meters per second squared. So we'll notice that M1G here is 39.2 newtons. And looking at these two external forces, because 39.2 is greater than 20, that means that the block is going to stay on the surface. And so we can now proceed with the problem. The other question that we have is which side wins. So in other words, M has got a gravitational force pulling down, and there's a force going in this direction. Whichever one of those forces wins will give us the direction of the acceleration, whether the system goes this way or that way. So let's look at those two external forces. So because we're assuming that there's no friction in the pulley, that means that the tension on this rope is going to be the same as the tension on that rope. And so this force coming down from M is going to be down like this. It's going to be M2G. And then the rope is going to carry that force all the way up to this force, which is going to be the adjacent side of this force. So that's going to be 40, or F cosine, magnitude of the force cosine of 30 degrees. And so another way to draw this is we can just, because this force is going to be transferred by the tension, the M2G, we can actually just draw the M2G right here. M2G. And now, just like with the last problem, we're going to see which one wins. So cosine 30 times the force, which is 40 newtons, that gives us 34.6 roughly newtons. And then M2 is 2 kg times G, which is 9.8, gives us 19.6 newtons. Now you'll notice that the force on this side is winning. So we now know which direction the acceleration will go. We know that this system is going to accelerate this direction with some magnitude A. And because we're assuming that the system will have the same acceleration everywhere, then the acceleration will also be A for M2, as well as for M1, which is twice the mass of M. So that's just some first preliminary stuff that I like to do. Now we're going to go ahead and erase this and start with our true free body diagrams. So those were the external forces. Now what we're going to do is draw a free body diagram. Let's start with mass 2. So I put my dot. I make sure to indicate that I'm looking at M2. And we know that downwards we have that gravity force, M2G, and upwards we have the tension force that's pulling back. And so that's actually it for our first free body diagram for M2, is just the tension of the rope and the gravitational force. Now let's draw our free body for this M1, which is twice the mass of M2. So now we've got not only Y forces, we also have X forces. So pointing upwards, we're going to have a Y component of this force, and that's going to be F times sine of 30. And we know that because it's on the opposite side, so to find the opposite, we're going to take the magnitude times sine 30 to find the component that's pointing up. Then we also have a component of that external force going to our left. That's going to be F cosine of 30 degrees. We know that there is a gravitational force that points downwards that is M1G in magnitude. And then you'll notice if there's a tension going this way, there must be a tension going that way. So we'll draw in our tension force. And these tensions are going to be equivalent. So in other words, T here equals T there. And there's one more force that we have to account for. Remember, M1G was beating F sine 30, which means that we're going to have a normal force because it's staying on the table, so the table must push back. So those are our two free body diagrams for this pulley problem. And let's go ahead and save writing the sums of forces for Newton's law. Let's save that for next video.